right, hi guys. So you have just made 3 models, or actually you've made 2, and then you've taken a guess on the third. The first was connected by straws. All right, it was connected by straws. The second was connected by strings. And then we learned that the third was connected by nothing. These 3 models represent solids, liquids, and then gases. So we're going to just take some quick notes. They're very quick on these 3 states of matter. Solids, liquids, and gases are states of matter. And there's 3 major ones that I want you to know. Solids is the first, liquids is the second, gases is the third. All right, let's dive on in. So in your notes, you have this beautiful graphic organizer, and it's going to discuss solids, liquids, and gases. I'm going to give you some more information about them. All right, so solids, they are when the molecules are really close together. All right, so they're stacked on top of one another. Okay. My drawing is not completely beautiful or accurate, but you get the idea that solids are stacked on top of one another. Liquids have, as you noticed in your demo, they have the same distance as the solids, but they're able to flow a little bit more, so they kind of get mixed around each other. They're kind of messier. And then gases, they just don't even stay near one another. They're just random. We can even get rid of a few of those because honestly, they just kind of float into space and do whatever they want, but they are not attracted to each other. So this is your solid, this is your liquid, and this is your gas. Okay. To go from a solid to a liquid and gas, we need to increase heat or temperature. All right. So my gases are hot, 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 and my liquids are cold. Okay. Liquids are cold, gases are hot. All right. So from your models, you saw that the intermolecular forces for solids are strong. So just so you know, guys, I'm going to tell you up here, intermolecular forces IMF. I'm going to just abbreviate them to be IMF, okay? So the intermolecular forces for solids are strong. Okay? Solids are rigid. Okay? They can vibrate in their spot, so they can move up and down in their spot, but that's it. So we call this vibration. They can vibrate in their spot, or the molecules, I guess. The molecules vibrate in their spot. They have a definite volume. / shape. meaning definite means like it's not going to change. So not changing shape. All right, so they have a strong IMF, the strongest. They are rigid. The molecules vibrate in their spot, and solids have a definite volume and shape. They are also cold, and they are slow moving. Because they simply just vibrate in their spot. What else do I want you to know about solids? Solids are... No, that's pretty good for right now. So they have strong intermolecular forces, they're rigid, the molecules vibrate in their spot, they have a definite volume or shape, so it's not changing, and they are slow moving. Okay, liquids. Liquids have a medium. So the IMF, the intermolecular forces, are medium. Okay, they flow, the molecules flow around each other. Okay, so we have intermolecular forces, which are medium strength. The molecules in the liquid flow around each other. As you could see in your model, the liquids are connected by the string, and you can move them around each other. They're still attracted to one another, but they can kind of dance around one another, all right? They do not have a definite volume or shape. I guess no definite shape, but a definite volume. Okay, so if I have a milliliter of water in a cup and I pour it into a bowl, I still have a milliliter of water. Is it going to take a different shape? Yes. Is it the same volume? Yes. So no definite shape means that it will take the shape of its container, okay? It's going to be hard to fit up there, so let me erase that. Oh, I don't know if it wants me to. There we go. So it takes the shape of its container. So it has no definite shape. All right. But it has a definite volume. So it keeps its volume. Okay. And now for our friends that are the gases. So our gases have the weakest or no IMF. Okay. The molecules move randomly. Okay. It has no definite shape or volume. And then these guys are fast moving. All right. The last thing I forgot to tell you about liquids is that they are they're medium moving. Okay. So again, our solids, they are close together, they are rigid, they vibrate in their spots, they have a definite volume and a definite shape, and they are slow moving. They are cold, okay, and the IMF forces are strong. Liquids, the molecules can flow around each other. They have no definite shape. They take the shape of their container, okay? They have a definite volume, so they will keep their volume. And they are medium moving, and they are medium temperature because they're between the cold and the hot. Oh, Nash is deciding to scratch his face right now. Good boy. Okay, and then our gases, they have no intermolecular forces between them. Their molecules move randomly. They have no definite shape, no definite volume, and they are fast moving because they are hot, hot, hot. The intermolecular force is what allows these three phases to be their phases. So because the intermolecular forces are strong in solids, the solids molecules can't move because they're so strongly attracted to one another, which is why a solid is so rigid. But in a liquid, the intermolecular forces are medium, so the molecules are still attracted to each other, but they can flow and move around one another, which is why that liquids are super flowy. And then gases, they have no intermolecular forces, so there's no attraction, so they just kind of get to move randomly, sporadically, wherever they want to go. All right? Okay. Those are your notes for today. The timer is about to go off in class, I'm sure. So please get yourself ready for this next section, which is the simulation. So you're going to go to this link here, and you're going to answer questions about the things that you see. Okay, nice work, guys. Thank you again. You got this.